Okay, lesson 9.6 is all about solving right triangles. So first we're going to talk about the inverse trig ratios. Okay, so we're going to let A be this acute angle. Okay, and we have the inverse tangent, which says that if tangent of A is equal to x, then the inverse tangent, which we write as tan to the -1 power of x, is equal to the measure of angle A. Okay, so notice how my x and my A switched. So if I want to solve for the angle, I use the inverse. Okay, so then we have the inverse sine. We have if the sine of A equals y, then the inverse sine of y equals the measure of angle A. And then if the cosine of A equals z, then the inverse cosine of z equals the measure of angle A. Okay, so like before, if you had like 2x plus 3 equals 5, okay, the inverse operation of adding, remember, is subtracting, so we would subtract that over. So we get 2x equals, 2, okay, and then the inverse operation of multiplication is division, so we would divide by 2 to get x equals 1. Okay, same thing here. If what I'm solving for is this angle A, I know this value x is some number. To get these to switch, I have to do the inverse operation, and to do the inverse operation, it's just the inverse of that trig ratio. Okay, so if I come down here to example 2, it says let angle A, angle B, and angle C be acute angles. Use a calculator to approximate the measures of angle A, B, and C. Okay, so we're going to rewrite this as the measure of angle A is equal to the inverse tangent of 0.75. Okay, then in your calculator, to get the measure of angle A, you hit second tangent, and you'll come up with a tangent to the -1 power, and then just plug in 0.75 and hit equals, and you get 36.86, which we're going to say 36.9 degrees. Okay, now we have B here, so I want to solve for B. So the measure of angle B is equal to the inverse sine of 0.87. Okay, so then I hit second sine, 0.87, and I get 60.5. So the measure of angle B equals 60.5 degrees. Okay, the last one now is finding the measure of angle C is equal to the inverse cosine of 0.15. So I hit second cosine and then 0.15. And you get the measure of angle C is equal to 81.4 degrees. Okay, notice that those are all less than 90 degrees, which makes sense because it said at the very beginning that those are all acute angles, first of all. And second of all, we know that we can't ever use 90, and we're not going to have an angle that's bigger than 90 in a right triangle. So those would be our answers for that. Okay, go ahead and turn the page. Okay, so we have solving a right triangle. It says to solve a right triangle means to, and you're going to fill in, find all unknown side lengths and angle measures. Okay, it says you can solve a right triangle. It should be when you know either of the following. 2 side lengths is one option, or the other option is 1 side length and the measure of 1 acute angle. Okay, so if I'm looking at example 3, okay, I have 2 side lengths, so this is like our first option here. Okay, so I think the easiest way to find our missing side length is to do the Pythagorean theorem. So I have c squared equals a squared plus b squared. So I'm left with c squared equals 2 squared plus 3 squared. So c squared is equal to 4 plus 9. C squared is equal to 13. So c is equal to the square root of 13, which is approximately 3.6. Okay, then I need to find the measure of angle B and A. So the measure of angle B, I have opposite and adjacent. So that would be equal to the inverse tangent. Opposite is 2 over the adjacent is 3. So second tangent, 2 divided by 3, enter. And you get the measure of angle B is 33.7 degrees. Once I know one of them, I can just take 180 minus 90 minus 33.7 to get my last angle, which would be the measure of angle A. So 90 minus 33.7, because that's the same thing as doing all of that. And you get 56.3 degrees. Okay, so then I have all 3 sides and all 3 angles, so that triangle is solved. Okay, looking at example 4. It says solve the right triangle, round the decimal answers to the nearest tenth. So I'm looking for the third angle, so that's really easy to find. So let's just do that really quick. 90 minus 25 is 65 degrees. Okay, then I need to solve for G and H, lowercase g and h. Okay, so if I am at H, okay, G is adjacent, and I have the hypotenuse. So I'm going to use the cosine of 25 is equal to G over 13. Multiply both sides by 13, so I get 13 times the cosine of 25. And I get that G is equal to 11.8. Okay, from here you could do the Pythagorean theorem to find that last missing side if you want, but I think it's faster to just still use trig. So this is going to be opposite, and I still have the hypotenuse. So then I'm going to do the sine of 25 equals h over 13. Multiply by 13, so I get 13 times the sine of 25, and h is equal to 5.5. Okay, last example. Example 5 says your school is building a raised stage. The stage will be 30 feet long from the front to the back with a total rise of 2 feet. You want the rake, the angle of elevation, to be 5 degrees or less for safety. Is the rake stage within your desired range? So I need to figure out what this x value is, which is pointing to, I know it's really hard to see it, which is pointing to this angle, okay? So I'm looking at, we want this over here to be the opposite, and we have the hypotenuse. So I have the sine of angle x is equal to 2 over 30. Okay, remember to get those x and that number to switch, I have to use the inverse sign. So sine to the -1 of 2 over 30 is equal to x. So second sine 2 divided by 30. And I get that x is equal to 3.8 degrees. So it said you want the rake or the angle of elevation to be 5 degrees or less for safety. Is the stage within your desired range? It would be yes, because it's less. 3.8 is less than 5. Or less than or equal to, I should say. Okay, because it could be 5 as well. Okay, so that's all you need for those notes. Let me know if you have any questions.